Very good morning to all. As
Good
you are
morning.
aware, today we have very important topic related with our air pollution and challenges in its metrology. We have with us Dr. Rajendra Prasad. We are very aware, very much familiar about this name because the first president of India was also the Dr. Rajendra Prasad.
G. Yes.
He is CEO of Ecotech Instruments. He earned his PhD in chemical engineering from IIT Roorkee long back in 90s, worked as managing director Envirotech up to 2008 and set up Ecotech in 2009. He has 33 years of experience in monitoring air pollution with source emissions and ambient air quality, etc. He is a recognized NABL lead and a technical assessor for accreditation of testing and calibration laboratories in India. He has credit as trainer of SARC countries, including Iran and Mali, on behalf of UNEP or UNDP. He is the technical coordinator for preparation of BIS test methods for air pollution monitoring, the main consultant for IOCL, NTPC, Tatas, etc. for environmental appraisal projects. Sir, thank you very much for accepting our request. I would like to also congratulate all the participants on today's International Women's Day, which is used to be celebrated every year on 8th of March. As we are all aware, government is working proactively to remove this gender-based comparison and to create a very harmonious environment for all the people of the country to work together. Thank you, sir. Thank you very much. I'd like to request Shri B. N. Dixit, our Director Legal Metrology, to kindly speak to us, sir.
Yes, Ashutosh ji.
Very good morning, sir. Please.
Very good morning. Sri Ashutosh ji, Director Legal Metrology, Government of India, and Dr. Rajendra Prasad ji, eminent scientist for the air pollution's measurement and expert in that very field. The air pollution has become very important things in our countries because day by day in big cities there is challenges of the air pollutions. Due to air pollution, the human's lungs are being affected immediately, and their working strength also being affected. So in metro cities, this is the very big challenges, how to reduce the air pollution. And scientifically, the measurement of the air particles, which are very nano particles, collecting that pollution, uh, some air particle from the air from where this polluted airs are available there, and to uh, measure the particles that may be the carbon, that may be the other particles which are not known to everybody there. So calibration and measurement is very challenging job there, and that is done by the organizations like where Dr. Rajendra Prasad is the MD of that very organizations. So I request Dr. Rajendra Prasad to express his views and thoughts so that all the people who are participating in these very programs, they may be benefited, and they we may get the advanced knowledge of the air pollution and that how these things are being measured, and how uh, because in TV also every days uh, the air pollutions of the important cities are being highlighted by government of India. So this is very important things, and Dr. Rajendra Prasad lecture will give us the good knowledge and good knowledge sharings, and we will be benefited from his views. With this very word, I request Dr. Rajendra Prasad to take the start the presentation and submit his views before the participants. Thank you, Sarjay. Thank you,
Thank you,
Thank
pastors.
you
Diksha
very much,
sir.
sir.
Thank you,
Thank you.
Diksha
Thank you
sir.
very much, sir.
It's a very kind word, and you have really created interest of all participants to really come in the zone where the problems in our urban area or in our country is facing. And I feel that some of my experience I will be sharing. I will be giving the gaps which are there. They are a kind of a challenge for scientists who is really doing assessment of air pollution. What are the limitations? What are the problem he is facing? What are the possible solutions? And we will also make a case study or a kind of a documentation presentation at the towards end of this, so that we can have a feeling that what more need to be added into the method so that more clarity comes. The HC has very rightly said that urban areas are becoming kind of a unsafe area for the health because of the air pollution. So I have a small uh, presentation of 5-10 minutes that I will include. We have not added in this presentation, so I will give some of the inputs or some of the control measures need to be thought, need to be implemented for improving the air quality in the city. With this background and our introduction has already been given, I started my career in the air pollution measurement way back in 1987 after completing my PhD. Immediately, my interest came in this field when I realized that air is very vital. I'm going to give you some interesting thing. I think number of you may be understanding it, but try to start feeling it. uh, Without food, how much we can survive? We can survive several days. You know that we take fast for 9 days, 10 days, and even more than that people can survive without food and without water around a day, 24 hours or so. But you see how much time we can survive without air. You close your nose and you will feel that not even a minute. uh, so air is very, very vital. Air is very, very important. And you see, without this its vitality, besides that, there are several more aspects of it. You see that if your food is contaminated, you can postpone it, or you can wait for the good food to made available. If water is polluted or water is contaminated, you have options to really filter it, or you can boil it, or you can pass through RO. But suppose if air is polluted, ambient air which you are breathing, what options you have? You have very limited options. You have no other options except to really take those harmful molecules or harmful particles loaded with some bacteria, loaded with some viruses, ultimately goes into the most delicate part of the body, that is called lung, and ultimately the damage take place. So I've already highlighted to you that air is very, very important. Air is very, very vital. So let us 2-3 slides see very basic things. Then we will take you further in the subject. Uh, this air pollution, I think every one of us are understanding. It is a presence of any substance, solid, liquid, or gas in atmosphere. Atmosphere is that where we are living. Our plants are there, buildings are there, human beings are there, animals are there. That may or may tend to be injurious to the humans, animals, plants, property of, or the atmosphere itself is referred to as air pollution, and the substance as air pollutant. So these two terms we will keep on communicating. air pollution and air pollutant. Air pollutant are those things which have come into the pure air. We know the air composition: 78% of nitrogen, 21% of oxygen, and 0.03% of carbon dioxide, and then many other things. So we if some inert gases and other things, if we are putting anything, maybe particle, maybe sulfur dioxide molecule, nitrogen oxides molecule, H2S, ammonia, ozone, whatever organic, inorganic pollutant, this air start losing its real use for the environmental component. I already indicated the components are first human health, then the animals, plants, building, vegetable, everything. Now, if we are not doing anything, then this air will remain like that. So we have to do some activity, and any activity gives some emissions. So these emissions will come into the atmosphere, and they will present into the air. Then there is air is having some uh, assimilative capacity. This will, whatever is came new, ultimately nature will also keep on removing it. So that is called the assimilative capacity, how much it can remove, and the same quantity it is coming, then we can say that there is a balance, so air quality can be maintained. So this is the such a concentration, this is most important part, up to which concentration it is not going to have very serious impact on these all the component of the environment. As I indicated here, you see that this is the clean atmosphere. If we are adding anything in this, it is going to affect. And if it is going to affect, definitely this is the point where we have to understand. And here this such a concentration which you have written, we have to really make a balance in between. So understanding of pollution, you might have got little more exposure. And now let us proceed further. What are the basically pollutant? There are six criteria pollutant, and then all non-criteria or the secondary pollutants. Criteria pollutants are those pollutants which are generated and emitted as it is into the atmosphere, like the particulates, PM10, PM2.5, PM1, or nanoparticles, whatever by due to some activity comes, they are one pollutant, particulate. Then because sulfur is present in our fuels, either it is coal or it is any other oil fuel, so that sulfur combines with oxygen, it gives the sulfur dioxide. It is acidic, all these gases are acidic. Then the nitrogen oxide, plenty of nitrogen is there, oxygen is there, high temperature while the burning is taking place. Whenever combustion takes place, these pollutants are coming. Lead, ozone, and carbon monoxide, unburnt basically carbon. You cannot completely burn it, so they are considered a criteria pollutant. Then there are many other things which are not desirable to be present into the atmosphere. There may be many heavy metals, there may be acidic gases like H2S, there may be alkaline gases like ammonia, there may be mercaptans, there may be vinyl chloride, then there may be asbestos fiber, the total organic compounds, benzopyrene, formaldehyde, benzene. These are all the pollutants which are basically formed into the atmosphere once they combine together, and they by some processes also they are coming out. So you have got an idea that there are particulate and the gases, there are criteria pollutant and non criteria pollutant or the secondary pollutant. Now you see that the objective today of the presentation is to really give you an exposure how to really do a air pollution management and control. Of course, I will come on this at the last part. First part, I want to show you the challenges for your slightly more exposure and understanding where we are at this stage. So that part we will be covering in the last part of the presentation. Then this air pollution management or the control is the reduction of this pollutant. You have understand that what I want to, or I mean to say, pollutant emission to a point such that no noticeable adverse effect associated with basically pollutant. To determine extent of reduction, understand, establish linkage between source and the receptor using metrology. You see that at some point it is emitted, and receptors are spread all around the atmosphere, and metrology. Metrology is the wind speed, wind direction, temperature, humidity, mixing height, stability, then the wet barometric pressure, rainfall. All these parameters are part of the metrology. They affect the emitted pollutant and impact on the receptor. So we have to understand these linkages between receptor and the emitter. Understand and establish safe air quality level for the receptor. You see that what that is called the basically standard. You see that if we say that standard is 50 microgram per meter cube of say PM 2.5, then we say that at that level it is not going to impact our various receptors, including sensitive targets, significantly. So we can tolerate up to 50 microgram per meter cube, and this standard is not arbitrarily chosen. This number standard which is notified, they are based on the health studies, based on the evaluation, when it's a number of research carried out. So this number is given that up to this point the level of the health problems, the quality of the fruits, the quality of the agriculture crops, the impact on the building, the life of the building, many things are there. So this is standard of various pollutant, PM 2.5, PM 10, SO2, NO2, CO, many other, ammonia, ozone, they have been notified. There is a good study carried out, and ultimately this number is given. WHO also given some number, other developed country also given some number. They depends upon their basically climatology, and these standard which are given for our in country, they are related to the conditions prevail in our country. So they are basically the primary health standard. Then the secondary standards for the vegetation crops, and basically the sensitive area. Sensitive areas are those areas where, like a hospital, like ecological park, where or those areas which we want to really keep them preserved for very long period. Taj Mahal is a monument, but definitely we want that this should survive for several generations. So there is a sensitive target. We do not want to impact those monuments, those buildings, those patients which are in the hospital. Schools are in the sensitive target, sensitive area where the children are. Our future is basically there. We want that they should not get impacted. So the standards are given, uh, health, primary health standard, and then the standard for the sensitive targets. Now, the challenges for how to manage air pollution is very important, which you have to understand at this stage. The problem is three-dimensional. You see, it is not very simple that maybe once the pollutant has reached into the atmosphere, very difficult really to resolve this problem. The transport medium is beyond control. You see that once it has come into the dynamic area, this pollutant will keep on moving in all the area, and they will create impact, and ultimately effect will be there. The impacts of pollutant is instant and chronic. Sometimes it's instant that we will see that burning in the eyes, so okay, you can move from there. But suppose if it goes into the body and creates some serious impact, and it become chronic respiratory diseases, ultimately you are exposing every day for those kind of the labels which are observed in the urban area where the concentrations are there, and ultimately impact is taking place. Receptor remediation almost impossible. You see that once the pollutant has come into the air, now you start thinking that we will be able to remediate. No, it is very, very difficult and almost impossible. You but maybe knowing this smoke towers which are made for several crore rupees here in Delhi, we thought that the pollution which is there in the urban area, we will filter it and dust we will remove, then the label became. It is not possible. It is, nature is such a big thing. So keep this mind that once it is going into atmosphere, very difficult to really remediate it. Solution cannot be delayed. If you are delaying, then the impact is going to be severe. Besides this, in Paris 2015 also, that emission need to be reduced for this carbon dioxide even. Around by 35% by 2030 from level of 2005. So this is the carbon dioxide and or the greenhouse gases emissions need to be reduced. Achieve 40% cumulative electric power installed capacity from non-fossil fuel, that this thermal power plant or other things, they have to be this capacity 40% cumulative electric power need to be basically installed. That is a requirement for a global requirement. Create an additional carbon sink of 2.5 to 3 billion tons of CO2 by 2030. So the more CO2 is coming into the atmosphere, we have to think of reducing it, because plants can consume only at a limited quantity of the CO2. If more CO2 remains, then definitely the temperature rise take place, and then there are many detrimental effects. So these are the things need to be done. And type of remediation is medium remediation, source remediation, and receptor remediation. Now let us come to those challenges. I have given you good background. Now you see that someone wants to do the air pollution measurement. uh, that is the most important part. What we need a certified machine, published method, and competent manpower. These are the 3 points which need to be there. Then only we will be able to generate a reliable number. You, this sampler must be based on the standard design for designated measurement, duly certified and calibrated with valid traceability. The system, whatever it is giving the parameter, this parameter should be calibrated. Those parameters which are participating in the calculating and giving the values of the pollutant. And if we are want to do the sampling of the particulate, that design and things need to be of standard design which is used world over. And they should be certified for the known concentration if they had been operated. What was the known concentration and how much the concentration is given by the unit. So that becomes the certification. Suppose we are operating a sampler in 100 microgram per meter cube dust, and that sampler is also giving 99 or 101 or 102, we can say that okay, it is at par, then we can certify that system. So we require a kind of a machine which give within acceptable level that concentration of the pollutant which is in which that is prevailed, so that we become confident that yes, the value given by the machine is all right, it is a certified one. Now published method, standard method notified by BIS, most suitable for our country, must be used, else use European Union, ISO, USEP, ASTM. These methods are, they are called the standard method. Standard method is a basically kind of instructions and the steps outlined, which are made by a group of people who have really done these measurement, done these or used that method, given his experience in that method, and ultimately details are mentioned. So standard method should not be modified, it should be accepted, and SOP need to be made complying with the standard method required and implemented in total during measurement. No bypass or nothing need to be required with this. Now the third thing which required is a competent manpower. Competency has to be understood, that the person should be qualified. Qualification has to be for that he has studied that kind of the subject in his academics, and then he has been exposed to this with the experienced person to learn and have the skill generated, and he has been given training or the hands-on training he has been given. Then only he will become basically competent. I competency I can also explain to learn in a layman way, that suppose we have a very good kitchen and all the good materials are there, and all masala, vegetables, good gas, chimney, everything is there, and we put a person there in the kitchen to make some food, and if the tasty food he can make, I think I will say that he is a competent person. Competent person get involved in that. Same thing is happen here. Competency should be that for what we are hiring or for what we are putting that person on the job, he should be able to give a number which should be reliable, and it should have all that flavor for which the basically that person is get involved, and he should have that qualification, learning, and he should do that experiment with that. So I made clear that these three things are very important. Now you see that what is happening in our country. Government of India has invested enormous financial resources and scientific manpower to create a formidable infrastructure in India for air quality monitoring to know quality of air regularly. All these things which I'm mentioning here, they are based on my own exposure and understanding. So they are not taken from anywhere, from somewhere or that. I'm giving you my own experiences. I may be some point you may feel that I may not be 100% right, but these are my experiences. So please take them in that spirit and see that what possibility we can do to improve upon. We know that monitoring is key and first step towards management and control of air. Therefore, it is responsibility of the lab monitoring groups to work honestly, ethically, and passionately in mission mode to generate reliable number for the credibility. This sentence or this thing I want to once again read, that this people who are working in the laboratory or in the groups, they should work honestly, ethically, and passionately in mission mode, that our objective is to really do the measurement as correct as possible, because that number on which only we have to really plan so many things. We'll say that it is polluted, it is not polluted, if polluted, how much it is polluted, if action need to be taken, what action need to be taken, which action is appropriate. All these things are built on that. Since generated data are going to decide status and shall be used for the management and control, should be published only after thorough evaluation and quality checks. In last 2 decades, exponential growth in the testing laboratory has been found in country. Accreditation under ISO 17025 almost mandatory for doing the business. You see that now if you are having a laboratory, if you are not accredited, accreditation is a kind of that you are competent to do that work. So if you want to do business, you have to have a accreditation for your lab. Most of these labs are micro and small in category, generating emission and the air quality data against contract given by the project owner, who get the measurement done and submit status report to regulator of their choice. You see that the person who is polluting is having the power, that he has to hire someone and he will get the data generated and submit it to the regulator and will say that yes, we are not polluting. So this is happening in our country in last several decades, and I feel that this process need further evaluation and understanding. If a project or the polluter, you are given this responsibility that you have to get your assessment done by a laboratory or by a group, and you have to make the payment for their services. You will not make the payment to that service provider, and you will be able to get report or the results manipulated or maybe impacted, and then the true things will not come. So this is the one major challenge which is observed and which is in between taking place in the country. Now you see that the growing inter laboratory business competition. Now there are large number of the labs set up. Among the private labs created mass. Basically what has happened, that several, I think 7 8,000 testing labs are there, and ultimately out of this around 1,000 or more than 1,000 environmental monitoring labs are existing in the country. ISO 17025 protocols are compromised because there's a lot of interlaboratory business competitions and they are bypassed. Manpower competence is not continually improving. This is a basic need, that every time your competency of the staff and the laboratory has to be increased, but it is not improving. Whatever I saw, I did several hundred lab uh, assessment, and this is my finding, that this aspect is getting compromised. The teams are not participating in competence enhancing training programs or the conferences, so their exposure is not really increasing, and they are not able to really achieve the objective of this ISO 17025 the way it is desired and the way it is implemented. SOP are SOPs are also compromised. Number of you are making SOP from the method. Some of the things which are you are not having, you are basically neglecting, you are dropping, and ultimately what will happen? It is going to impact the value. And if the value is impacting, then that ultimately that all your efforts is basically going to the waste. Poor quality consumables are used on the face of the lower price of the monitoring being offered, because what happens that for the competition you have to really give the price, keep on giving less price. I remember then in 1987, when I started, I did several thousand monitoring of the stacks and the ambient air quality. At that time we used to take 2000, 3000 rupees per sample. And you see from 87 to this 2025, there are almost 4 decades, the rupee, how much it is devaluated and what cost it has come. Our salaries were of the order of 2000, 2500 in that range, and when we started it. So, and that the price of those kind of the monitoring is also prevailing at this stage, so that gives the kind of a dissatisfaction, because you are giving such a low price where you will not be able to do justice. And ultimately what happens that you are compromising by using the poor quality consumables, and work is being done in unrealistic time frames. We are saying 24-hour value, you are even not operating sampler for 24 hours, you are not operating samplers for using desired chemicals, desired filter papers, the not putting the competent people or the experienced people, then definitely the quality which you are generating is having a serious impact, or the serious lacunae on the results which you are generating. Calibration of units being used in one of the important aspect found at last bench of the quality control, almost neglected and bypassed. So basically this data quality issues are there. You see that what I observed, I see that a lab is having 20 sets of the equipment, and they are getting one set of the equipment calibrated to show to the auditor and to prove that yes, we have got this instrument calibrated. Large number of the units which they are using in the field, it is not calibrated. Their values of the critical parameters which they are monitoring are really having significant errors and leakages. And the problem then, the whatever value they are reporting, the confidence on the value is not coming. Such testing pose serious risk and danger to life of the people, where no control and the management is being exercised by the polluters. GEM has also become a platform where rates are played, and as a government mandate, work is ordered to L1 bidder. And here you see because of the interlaboratory business competitions, people keep on giving lower price, and then ultimately at the end, once the order is received, the problems basically to cope up with that business, they compromise a number of aspects. Now let us further go deeper into the experience what I gathered in the past. Accurate and reliable measurement of air pollutant is a challenge due to wide range of the pollutant concentration. You see that the besides that gam business and other issues, now let us go to the subject. You see that in our country there are areas where the concentrations are 20, 30 microgram per meter cube of some PM10, PM2.5, but there are areas where these concentrations are 500, 600, 900, 800 microgram per meter cube. This means our system should be like that we can have the lowest value measurement and the higher concentration measurement. And we are not having a system for the low range you can use this, high range you can use this. Our regulation is not really talking of anything on this. And ultimately they say that this instrument, this notification, this method, and whether that method is having what kind of the accuracies, what kind of the error, so that is creating a serious challenge. Then you see that the harsh and variable climatic conditions, somewhere it is very low temperatures, but somewhere it is very high temperature. Recently I was talking to Ladakh, they are having -25, -30. That same regulation is also applicable there. whether these machines will work there, whether these methods which have been prepared, they are going to be applicable correctly, they will be able to measure these pollutants or not. These issues are there when this barometric pressure becomes 600 in the hilly area, in the Manali area, many areas where these measurements are being done. Those values are not going to be produced confidently if these things are those provisions are not incorporated in this. And the poor quality or the uninterrupted power supply is there, that you see that how much power fluctuations you are getting, what kind of the low mines you go, the voltage is very low, and you see that not lot of power interruptions are there. These are making these monitorings very difficult. And if you are not going to compromise, then definitely this becomes a kind of a challenge to really find a correct number, that what are the prevailing labels of the pollutant there. Now, the second part is the groups involved in the monitorings are from multidisciplines who never studied air pollution in their academics, because in recent past only, I think in a 10, 12 years back only, this environmental engineering or this course is added. Earlier, it was part of the civil engineering and then also part of the chemical engineering. And now in MSc environmental science in BSc, these courses now started. But people who are still involved in this, they are not having that academics, even though practical and the training and the technical trainings are not mandatory requirement at this stage. It is not said that somewhere they should have take this training, they should have the certified, they should have the exposed, they should work with the experienced people to skill development. No efforts are visible on the continual improvement in skill of the manpower and building ethics and honesty in the team. I've already highlighted this earlier. Inadequate documentation. You see that if our documentation is good, at least someone can refer, but our documentation needs, there are a lot of gaps. Specification of instruments are not clearly outlined. Sampling and test methods are not complete in itself. Guidelines are not really made so that if you want to work, you can interpret it or understand and ultimately implement them. Policy documents are having basically gaps. Air quality standards are also having those areas which are not clear, and person are getting confused when they want to make use of it. Thus escapes are there, and the people are finding or making benefit out of these escapes. You see now, let us come to the some more aspects: quality control and the quality assurance or the uncertainty assessment. These concepts or tools are not in the regular practice and never made a part of the reporting. You see that if you are reporting some result, uh, are you not feeling that you should also analyze a known sample and say that my known sample analysis is 2% or 5% variation we got, so we are ensuring that that quality control or the quality assurance we have checked. Quality control, you should have the better gadgets, better manpower, better basically system at your place. Uncertainty assessment is not done, and not understood also many times. Whenever you are reporting a number, you have to, this is not an absolute number, you have to say that what possibility of error is there, and the error is maybe because of the instrumental error, there may be the analytical equipment error, there may be the basically a climatology or the environmental conditions error, there may be error of the person who is doing the work is um, uh, in taking reading error may be there. So there are aspects, there are, it is already well defined uncertainty assessment, that is the type A and type B components need to be taken, and then one can find it out. This is the possibility that the value, if you are reporting 100, there may be 10% uncertainty or 5% or whatever it is. Monitoring gadgets are decided on the basis of their low cost. Man and machine both, I'm telling you. When we select a machine, we have to go for the L1. And then whenever we select a person, we also start thinking that whether we can get a person in the lowest possible salary. And then we are want to start expecting that the highest quality of the results we will be able to generate. You see that you have to have a professionally competent people, and then they will be able to work in honest manner, and you can utilize their skill and professional understanding. GEM is instrumental in implementing this. I've already mentioned. Resources limitation, incorrect budgeting, inappropriate allocation of the fund. You see that you buy equipment, very expensive equipment for the analysis, but you forget to really have the good consumables for it. You forget to provide a good room for it. You forget to provide a good power to it. You forget to provide a good person for its operation. So having basically one aspect you are saying will not compromise, but other aspects you are compromising, like anything. Transportation of these samplers, you are not basically thinking that if we are dumping into car and dumping into some transporting vehicle, it is going to have impact. There may be, because of the vibration, there may be some leakage may generate, the o-rings may cut, the many things are there. Basically no budget, no provisions are made, and ultimately they impact these things. Air pollution is also having a limitation, that cross verification is very difficult, and we are not having any system, not incorporated in our system, that cross verification should also be done by another independent system also, which should check, so that the operator, when he's doing, he should be double confident. No clarity in the objectives, and later at the end, results are hardly interpreted for achieving objectives. You see that in our country, thousands of online air quality monitoring stations are installed. Large quantity of the data is coming, and what is happening with the data? People are not interpreting, not basically reports are published. Now, nowhere it is said that these values are found fluctuating. This is appear to be impacted because of this activity, because of this activity. Only these stations are basically put only to meet the regulatory compliance that we have installed it. And at certain seminar or conferences, I have even heard from the regulator, they said that we have installed 3 online air quality monitoring station, now the pollution problem is gone. As if the monitoring you will be able to reduce or the eliminate the, because now you can manipulate the station to show that whether the values now pollutant concentration is low, so pollution problem is gone. That is the basically shows that our understanding requires further basically exposure and understanding. Our objective is to really see the label today, and after some time, once you are doing some control measure management, that what sort of the reduction is took place, and you should see that what labels are there and what kind of the system need to be used for that. Now you see the infrastructure part, if we concentrate, inadequate sampling and analysis instrumentation, erratic power supply, already said. Standby equipments are not really considered. You see that we are not planning. We feel that we are having 2 instruments, we will be able to, but sometimes instrument may go out of order. Instrument may not give the desired values. Then you will be able to use a standby. By that time you can set it. So this should be also part of the management. Spare parts and consumables for maintaining and operation of the instruments are not procured. Intermediate checking systems are not considered. We assume that once we will do get calibration done, then entire year it will remain stable. Even we are taking from one place to other place, we are not maintaining all the requirements as suggested by manufacturer. So that is really over expectation. Time to time it should be checked whether all the parameters values are coming. And 17025 is very clearly asking that monthly, bi-monthly, quarterly, these instruments need to be checked more frequently if you are using them in the field, so that you can see that whether the calibration or the values given by the machines are still remain reliable or not. Annual calibration of all instrument use are not done as per requirement. Only one set of the instrument are got calibrated. And now very interesting aspect is that errors observed during calibrations are not utilized for the correcting results. This part it is paining to everyone, and to me very badly. You see that you are getting some instrument calibrated, you are getting 1.5% error or 1% error, 2% error. What you are doing with that error or deviations? You are not incorporating that. You are keeping those certificate only to show to the auditors. This calibration is not done for the auditor, it is done for basically improving the results. Now, towards the management level, what sort of the things? Monitorings are not given adequate priority. Appropriate fund allocation of the instrument and the consumables are not done. Findings reviews are not done for any action on the results, because you number of online monitoring station, offline monitoring station, results are coming. Management is hardly bothered. They feel that we have complied, and all the time they want to record should be made like this, that everything is all right, no pollution levels are well within the standard, so nothing need to be done. And if it is beyond that, even though they will not report that, if it is beyond that or emissions are beyond that, they will keep on reporting everything is all right. If everything is all right, then how these problems in our country seen everywhere? The labels are more, and the health problems are there, the many things are there. So these things has to, management has to look into it. Provision of inadequate manpower, because if you are having good capability, doing good work, you will be shifted to the production, you will be shifted to the other area, sales. But for the environment, you are putting those people who are really they are not very productive, then you say that you will put you into that field and you do work there. So these are the aptitude of the basically organizations, management level, or the industry, or those areas, or where you are basically finding that the people who are managing these environmental monitorings, they are basically those teams which are less exposed and less professional in that area. Confidence of the top management is not reflected on the quality of the data. You see that if you talk to the member secretary, chairman, or the managing director of the pollution control board or the industry, the people feel that no, the whatever data generated, they are only fulfilling a requirement. We are not really honestly seeing the data is generated by us. We have invested money. Let us use it. If it is more somewhere, we have to do aspect those by which we can reduce it. Regulatory requirements are not clearly defined in orders and the notification. They are orders given or the notification given. The categorically some uh, vague thing, or maybe it is written, but not what need to be done, what need to be reported, what need to be maintained at your place, what need to be cross-checked, what need to be quality assurance, what need to, these things are not really documented anywhere, and ultimately they are basically completely ignored and they are not looked into. Specification of instruments are even not defined. NPL had been decided as certification body very recently, 3 4 years back only, and this air pollution is as old as it has come, Act 1981. So if we, how much time we took to really certify a organization or the body that they will do the evaluation and certify the instrument, but yet to be established infrastructure and start their work, manpower is not there. Some instrument they have procured and the work is going on, something they have started, but still lot more need to be done. Instrument do not meet key requirement mentioned in the standard sampling method. Tolerances, accuracy, precision, permissible uncertainty parameter wise are not defined, not implemented. Instruments are not fitted with gadgets to overcome impact of the harsh Indian condition, extreme weather condition, fluctuating power, high levels of dust, static charge, low temperature, high humidity. These are the something which are also require attention. If these things are not really looked from that detailed point of view, they are basically when the people are using these things may not be able to really generate data confidently. Calibration and intermediate checking of the instrument are not available for full range with known uncertainty. Master used for the calibration must have valid traceability. If available, these are not used to check samplers and analyzer on regular basis. For dust sampling, proper omnidirectional insensitive to the winds inlet is needed with certified fractionating impactors. Device found compromised because of the cost cutting. Manpower challenge I've already highlighted, and I think once again highlighting them, no point. This is very important. We should be able to uh, see that the people have the regular training and the competence building. Now, practices what is required. Laboratory where analysis of collected samples are done should have accreditation. It is mandatory requirement. So one should have, and accreditation should be in true spirit. All analytical instruments also need to be calibrated to know their uncertainty contribution. Calibration factor and uncertainty must be accounted for before reporting the final results. Sample filter preservation and their transportation from monitoring site must be done at controlled, defined conditions. You should have a setup and you should be able to implement that. Filters should be used for the sampling only after their bait stabilization and conditioning. These filters, because a lot of air gaps are there, the moist air go there, then the water molecule remain there, and ultimately initial bait should be taken only after their conditioning. Balance of relevant accuracy is required for specific use. Filter desiccation and weighing must be done in temperature and RH controlled room. Sensitivity and resolution of analytical system must be carefully evaluated. Field blanks are not used to know the handling error. You see that the filter handling and conditioning system has significant bearing on the monitor dust concentration. In our country, dust is a major pollutant, and other gases and other things, other pollutants are also there. They are also important, but dust is taking the foremost seat. And you see that we are still using high volume respirable dust sampler for PM10 measurement. There we are using 8 by 10 inch filter sheet. And how to weigh this big size of the filter paper? There is not even a balance available which can weigh this. And you see, we are folding it, putting in a beaker, and then find it out its weight. Lot of basically challenges there. Size of the desiccator and the saturation of the desiccant result in incomplete conditioning. That part is required attention. Desiccators are not equipped to display prevailing temperature and RH in the chamber where filters are kept. One important thing which we have to understand, once we some method is developed, but at that time technology was not there, we said that high volume system is required so that the quantity of the dust coming on the filter paper can be weighed accurately. Now very good balances, 1 microgram accurate resolution balances are available. Why we are struggling with very big filters where the possibility of error and uncertainty is there? Worldwide small size filters for the air quality monitorings are used at low flow rates even when prevailing dust levels are several times less compared to India. We are lot of dust having because we have lot of desert, lot of areas in our country where the dust is generated and they remain into the atmosphere. Our regulation once published, um, uh, people are not amending, not scrapping. So this is also a kind of a basically challenge we should think of, that what remains relevant in today's technology. High volume sampler we are talking, which is way back in 90 we started, or 87 we started, and that is still going on. That even method or the requirement is not scrapped. Inadequate documentation in the method and the standard. They are saying 24 hours. I say that which 24 hours? I do not know. The midnight to midnight, morning 6 to 6, 10 to 10. People are reporting values of different 24 hours, so they are not comparable. Ultimately, in Ahmedabad, someone is doing some value, in Delhi is doing someone. We do not know that which 24 hours he has operated the machine and which 24 hours Delhi people have operated. So we need these kind of the clarity. I'm putting my effort in putting these kind of the things with the help of BIS, but still there are every area need to be given attention on this, and ultimately find it out what is possibilities. Consecutive, non-consecutive days are mentioned in the standard. There by bird it is clear, but it is not clearly defined. What happens? You say that the non-consecutive days, 2 consecutive days, 104 sample. That if you see that, then you will not be able to really check your data which you have generated for a year long. That their gap is there. Sampling flow rate for the various air pollutant is not clearly defined. For example, PM10 is done at 1 meter cube per minute in RDS, and also at 1 meter cube per hour in PM 2.5 sampler for PM10. Results obtained at these flow rates have the significant differences in uncertainty. Thus, PM10 data being generated at two flows may not remain comparable. But someone is doing with 1 meter cube per hour, someone is doing with 1 meter cube per minute. So these are the incomplete documentation, procedure, calibration frequency, accuracy requirement of the master are not specified in the method. According to ambient air quality standard, 12 pollutants need to be monitored to define quality of air. Some measure all parameter for 104 days as asked in the standard in a year. Some measure only few parameter quality or the criteria pollutant. Whether have this 104 days and remaining whenever have time and the resources. New standard came in November 2009. Still clarity is not documented which parameter to be monitored when and where. And you see that if you are telling 24-hour sample, whether exact 24 hours if you are running, then only you will consider it is a valid sample, or 10 minutes less or 10 minutes more. So validity of the sample says 75% of time it has run, then we will say that okay, it is a valid sample. Even this is not clearly marked with the standard method and the protocols. Now I'm going to make a case presentation, so only want to show you that these kind of the things required. I have lot of hopes things can improve. I've highlighted only those gaps which were there. Of course there are a lot more strengths available, but going to read two three more slides and show you that what is basically the in documentation required. We know in the dust levels in India is higher than western countries due to huge open land used for the agriculture activities, extreme seasonal variation, and vast desert. Big deserts are there and winds are there. So ultimately, this dust becomes suspended into the atmosphere and it goes one place to other place. And then we have very big cities. Urban centers are full of vehicles and cluster of many air pollution activities. Industries are there, road dust is there, many percent sources are there. Multiple instruments with filters are needed to collect 24-hour sample to know day-to-day variation in dust level. You see that one location, if you want to monitor PM10 and PM2.5, you need to have two samplers. And then if you want to do benzene and CO, you should have two more samplers. The gases you can attach with the respirable dust sampler. So multiple instruments need to be operated. In winters, foggy days, one PTFE filter for PM2.5 sampling choked within 6 to 8 hours because the levels are very high. Since it is difficult to predict choking time, it is a kind of a challenge to do 24-hour measurement. PM10 sampling using RDS is more difficult and unreliable even when multiple filters for 24-hour sample are used. Three filters one can use 8 hourly. RDS estimate respirable dust as cutoff of RDS is at 5 to 6 micron. Standard is for PM10 cut point at 10 micron, not for the respirable dust. So that these two values are basically not comparable, RDS and then the PM2.5, PM10. So this has to need a serious attention on that. Dust level prevail in our country are in the range of 100 to 900, even 800 200 in this PM10 values, and PM2.5 values 100 to 600 microgram observed in the winters higher value, and in the summer and in the basically post monsoon time these values are there. For such high level conventional sampler RDS PM2 sampler based on the very sharp cut cyclone or the winds impactor fitted sampler cannot produce a reliable result. It is well documented in the method. These methods which we are using, they are meant for a specific range of the pollutant, and everybody understand, everyone is written, but they are these same methods are used for the very high concentration of the pollutant. Conventional impactor based instrument found have serious limitation because what happens with large number of the particles are there, because of the high dust concentration, bouncing of the particle take place in the winds impactor. Non-uniform particle deposition, significant dust particle found lost on impactor surfaces. Oil-based impactor contaminate samples. Normally, oil-dipped filter is used to improve collection efficiency and reducing bouncing effect, but the molecules of the oil can also proceed with the air stream and ultimately um, uh, infect the sample. Sample collected using conventional impactor-based system are many times not useful for producing reliable analysis by the sophisticated instruments. You see that these are the two things I want to show you. This is our conventional system where this is a bins impactor. Here we are keeping a soft surface of the filter paper. Oil is kept here. It is hitting here, and ultimately the coarse dust remain here. This is a heap you can see here, and ultimately less than 2.5 micron dust goes to the filter paper, and ultimately this technology is there, and which is good only up to 200 microgram per meter cube if it is a dust, and this is good for 10 or one can say 5 microgram per meter cube to 200 microgram. That is the range of that method. And the same method is being used where the concentrations are many times more than 200, more than 300, 400. And then we feel that these values are reliable. I feel these values which are being reported using the same technology is very difficult to say whether they are correct or not. Then the another, that is the virtual impactor, is the one which are used for the higher concentration. It is well documented in the USEPA methods. You see what happens, that the total flow of 1 meter cube is coming here, and it is basically more than 10 dust is removed in first impactor. Then the less than 10 micron dust it is coming, and by inertia it keep moving and goes with the minor flow of 10%, 1.7 liter per minute here. And then the 15 liter per minute is sucked in another. Here you can, it is coming like this. So PM10 is get collected here, and 2.5, 0 to 2.5 get collected here, and all 0 to 2.5 to 10 micron is collected here. So one can find it out PM10 by adding both these, and PM 2.5 in fine particle impactor. So this is used for the higher concentration world over. For measurement of PM10 and PM2, sampler need to be used. This is not only cumbersome but also have many operational and the transportation difficulty. Some of these are difficult to transport. Shifting of instrument and monitoring site at 3 to 10 meter high needs overstretching effort. Obtaining two power point and ensuring satisfactory power supply in these points most of the time difficult. Ensuring two samplers operation exactly for the same time interval, and the maintaining recording two sets of the parameter difficult to manage, and known to have a lot of error. Many times the sample becomes invalid. In such management, many times regular sampling jeopardized, where loss of data thus resulting invalid sampling lead to compromises. This is the recent sampler which we have really evaluated and developed. We have developed basically since my uh, completion of PhD. We have done large number of the instruments which are used in entire country. They are all indigenous equipment with the earlier company, and then with this our the separated company in the brand of Ecotech. You see that the brown filter is showing PM10, and this is showing less than 2.5. So this is showing 2.5 to 10 micron. This by color also one can say that the both filters, they are connected here, and ultimately air is entering one. So one instrument is good for doing this PM10 and PM2.5 measurement. Of course, this Gujarat Pollution Control Board at Gandhinagar, they have procured some 15, 16 units from us. They are operating and they are doing, and very easily they are monitoring. So this is the latest development. It basically comply with that USEPA method, but of course CPCB has not yet notified this. They are still remain with that bins impactor, where the upper concentration limits are there. You cannot monitor more than 200 microgram per meter cube. Now I want to read this few PPT which shows that what a document, if the method is they are writing, what kind of the details are required to be basically added. So only for an exposure, of course, reading all these things is not going to, but only I want to give you a feel. The principle, I let me read this. An electrically powered dichotomous sampler draws ambient air at a constant volumetric flow rate into USEPA design inlet and through an inertial particle size impactor, where more than 10 micron dust is separated out. Now the air stream with 10 micron dust pass through a virtual impactor, where coarse and the fine fraction of the dust separated out, controlled by flow rate and size and the shape of the virtual impactor, and get collected in on two separate filter, coarse and fine, over the specified sampling period. Each filter is weighed to determine net gain due to collected coarse and the fine fraction of the dust. Total volume of air sample is determined by the measured flow rate at actual ambient temperature and pressure. The mass of the concentration PM10 and PM2.5 in the ambient air is computed by mass gain collected sample on the filter divided by the actual volume of the air passed. You see that the lower limit is 2 microgram, and this equipment can be used up to 900 microgram PM10 and up to 600 microgram per PM 2.5. Upper concentration limit and the lower concentration limit is very clearly defined. Required sample, it can be operated for 24 hours without any issue. It has a very heavy duty pump. It is not very heavy because the flow is low, that is the medium flow 1 meter cube per hour. This is recent development in last 3 years or so. Sampling flow rate is maintained at 16.67 liter per minute. Flow control is achieved through the microprocessor and the mass flow measurement and maintained at 16.67 lpm plus minus 5%. Flow rate cutoff, sample air flow rate control shall terminate sample collection and stop all sample flow for the remainder for the sampling period. In the event that the sample flow rate deviates by more than 10%, then automatically it is switched off. This is mentioned in their documents, and ultimately the sampler is designed to meet these requirements, and someone has to now certify whether these requirements are completely fulfilled. At this stage, whatever manufacturer is doing, he is doing for his own satisfaction and then start selling because certification bodies are not there. But now if these things are coming, I think it will become a lot of improvement in the process, and the quality of the data will come using these kind of the sampler now, which are certified. Cleaning of the lab performed by the laboratory analysts who are familiar with the laboratory equipment system and the gravimetric analysis operation. For refining cleaning strategy, ultraviolet fluorescent inspection of the surfaces in the weighing chamber need to be performed annually. These are written into their documentation. Shoe covers, disposable lab coats, and the power free gloves need to be used prior to clean the laboratory. Personal, they have mentioned that what kind of the personal what is required. Laboratory personnel will always wear clean clothes and wash thoroughly all parts of their body that may be exposed during the weighing only basically contribute your because you are doing PM 2.5, very fine dust, the particles on your body with your clothes, everything can contribute during the weighing. Laboratory coats and the gloves are required to minimize the potential for the laboratory contamination, so these need not to be moved out of the weighing room. That kind of the precaution required. Must be aware of the potential for the unacceptable relative humidity execution during seasonal extremes such as high heat and the humidity in summer. So this humidity control, temperature humidity control chambers are required, or the small rooms required. uh, Personnel employed to perform weighing operation must have the at least high school diploma with at least 6 month experience in laboratory sample handling and record keeping practices. These are very clearly mentioned in their standard method. uh, Lead analysis must have an at least a batch lead analysis, not the lead analyst who is the managing laboratory should be bachelor in degree in the laboratory science and at least 6 month additional experience in the laboratory. All analysts need to be trained to a competency before they are allowed to perform weighing operation. Sampler location, dichotomous sampler must have the unobstructed airflow for a minimum of 3 meters from all direction. If sample is collected with multiple particulate matter sampler, the spacing between sampler inlet must be at least 1 meter from co-located sampler. Height of the inlet should be within 1 meter as measured in the vertical direction. That you have to keep on the rooftop, then your inlet should be at least 1 meter away from the rooftop, so that by winds the dust levels are not increased near the sampler and impact the concentration of the dust. Now the analytical microbalance, which is required for the weighing, adequate to weigh the filter 100 to 400 milligram, must have sufficient room to weigh the type and size of the filter. Microbalance must have minimum readability 1 microgram per PM 2.5. Of course, in our country, labels are very high. So even 10 microgram accuracy balance can be utilized. But definitely these things should be outlined in the method. In BIS, when we wrote this method, we incorporate some of these things based on the own experience and based on the documentation and other methods. Repeatability should be 1 microgram. Balance must be calibrated at installation and check immediately before each weighing. Electrostatic charge buildup may need to be neutralized in the microbalance weighing chamber. What happens? We are using this PTFE, this Teflon filters. While sampling, the charge, static charge is developed. That charge need to be removed. Otherwise, you are getting incorrect weight of that because of the charge value increases. So you are bound to report the wrong value then. uh, Correct filter should also be used. You see that in our monitorings, what happens to compromise the cost? We are using non-standard filter paper only to save the cost. Their pore size, their collection efficiencies are less. Than ultimately, some part of the dust pass through the filter paper, and ultimately we end up with the lower concentration. This filter is called polytetrafluoroethylene filter. It is integral support ring. Their size, pore size, thickness up to 50 micrometer, 30 to 50. Pressure drop 30 centimeter. Water column at 16.7 liter per minute. Maximum moisture pickup, collection efficiency, and filter bait stability. 20 microgram is required. And many times you are weighing, it should not vary more than 20 microgram, one measurement to another measurement. Test for the loose surface particle contaminant. They have very clearly said that you have to do testing of the filter. After initial weighing, install each test filter in turn in a filter cassette. Drop the cassette from a height of 25 centimeter to a flat hard surface, such as a particle-free wood bench. Repeat 2 times for a total of 3 drop tests for each test filter. Remove the test filter from the cassette and reweigh that filter. The average change in the weight must be less than 20 microgram always, so that any loose particle which are added on the filter surface, you are not able to see by naked eye, can be removed and can be passed that yes, we are handling our filter rightly. Test for the temperature stability, alkalinity, these are all defined in the method. What I want to show that our method, whatever we are preparing, we are giving, we want that these kind of the clarity should be developed or should be incorporated with that. Weighing laboratory should have air conditioning, and including weekend, that temperature should be maintained and humidity should be maintained all the time. Locate the microvolans away from the potential sources of the drift, such as doors, windows, aisles, and with frequent traffic, ventilation duct, and the equipment with fans or moving part, it should be away from that. Locate microvalence out of direct sunlight and away from the local heating or the cooling sources, such as open flames, hot plate, water bath, or the AC air. Locate the microvalence on a sturdy vibration-free base, ideally stone being table, which should not have touch to the wall of it. Ensure the microvalence's base is adequate of adequate height, so that working should not have problem. So these are the some details I've shared with you, but definitely there are some more things I want to share that will give you more interest. This I've given more insight, what are the gaps, and shown you some of the um, area where what need information more needed, so that this reliable data generation can be visible in our country. In international community also, this they feel that the quality control or the quality assurance aspect, the data generated in India is not very good. So we want to really, we have to remove this kind of the stigma. So now we will be giving you first exposure to the instrument which are used for this, and ultimately then the control for 10 minutes. These are the kind of the instrument which are used for the air pollution monitoring instruments. You see that all the instruments, I have only given you a photo here. In the back you can see this is the uh, automatic weather station, gives the temperature, humidity. It is solar powered, it has the wind speed and the wind direction, and then the barometric pressure, rainfall equipment, everything can be connected. Hourly values or the 30-minute, 15-minute value can be done. This is called the respirable dust sampler. Then this is PM 2.5 sampler, these two. Then this is the combo sampler. Of course, dichotomous is not here. This is recent development. Black one is the emission monitoring equipment. These are the work zone monitoring setup, noise monitoring system. This is the carbon monoxide monitoring system. These are the gases pollutant measuring equipment. So these are the range of the equipment used for the manual monitoring. They are considered the primary standard. They are not the online monitor. Here it is online monitoring system. So let us peep into this. Is the high volume sampler used way back in 1982 onwards. Now there is no standard for it, but for certain fugitive emission monitoring, one can use this. This is the respirable dust sampler. Of course, I will not read all this. There have been the stand, the height of the inlet has to be defined. Air is entering from here and ultimately goes to a cyclone. The coarse dust is collected in the bottom of this, and ultimately fine dust goes to the filter paper. There is a manometer where you can find it out the flow rate. There is a time totalizer which give you the on time of the machine, and ultimately this the air comes here, goes to the cyclone, goes to the filter paper. Ultimately dust retained here is less than 10. More than 10 dust comes here, and ultimately the direct reading flow is coming. Gases attachment can also be attached to this. Then the PM10 and the four gases can be monitored: SO2, NO2, NO2, SO2, NO2, ozone, and ammonia. This is the kind of the opening of that filter holder. Here you are keeping 8 by 10 inch filter paper, and then this is the outlet of the cyclone, because suction is here, so all the dust and air passes through this, and ultimately the sample get collected. And this is the cyclone. This is a very clean surface or the glazed surface cyclone inside. The air goes inside, it moves this way, and the coarse dust accumulated fine goes up. Ultimately this is used, and this is the view of the sampler. Only just give you an peep. There is a stabilizer put it in the machine, so that the input 170 to 250 it is reduced to 220, so that we can ensure that the blower is getting the stable voltage, and ultimately maintain that RPM, and the flow also remain maintained. And this is the basically PM 2.5 sampler. Here you see that this is the unit where the more than 10 micron dust is removed and less than 10 micron dust goes down. And I'll show you that. Okay, this is the latest model. This is the mass flow controller base. It has the basically cloud connectivity also, where the modem is fitted inside. Whatever data logging is taking place for the flow temperature, barometric pressure, filter pressure, and all logged into the microprocessor based data logger. It has got a modem, so it also data goes to the cloud. So the cloud data one cannot be manipulated. What was happening, that the people were collecting the data, transferring data into the Excel sheet, and then used to manipulate it. So the CPCB we reported, and also they understood, and ultimately the method they have improved, and now data logging for the last 10 samples remain into the cloud, where there is no possibility of manipulating by the sampling lab or the testing lab or the groups involved in the monitoring. So that kind of the catch has come. This is the data recorded: date, time, then the operation time, flow rate, and then the ambient temperature, filter temperature, barometric pressure, volume, then the coefficient of variation. These records are available, and ultimately by that, this is the sectional view. Air is entering here, the insect are not going to enter, so the jali is provided, and ultimately the coarse dust PM10 and above remains here, PM10 and less comes here, and then the 2.5 to 10 remains in the bins impactor, and the bottom it goes the less than 10 micron, less than 2.5 micron dust. Bins impactor is the heart of it, and this is good up to 200 microgram per meter cube. This hole is most important, which is the cutoff, and the distance from this to this is most important and critical. These two things are maintained, then the performance of this impactor for the cutoff of the PM 2.5 is available. They are the designs made by the US EPA, published to be made by CNC. So they want that the entire globally the data harmonization should be there. Everyone should use the same technology, same flow rate, so that the data of India can be compared with Australia, India can be compared with the American, all the country data can be compared, so that data harmonization. We developed a combo sampler where the both things can be collected, but there are the two entry point here, 38 lpm, here 16.7. So this is also good and used for PM10 and PM 2.5 measurement simultaneously. So there's all the features which are there. With that, we got this certified by the NERI. They evaluated against that. These are the gases sampler. The flow meters are there. Then there is a mini butter. This thermoelectrically cooled plates are kept inside. the time totalizer, then the timer. The air, unfiltered air goes here, and ultimately after bubbling, the gases pollutant remain here and ultimately get connected, and then it goes to the pump, and ultimately gases pollutant free gas goes out, and the built-in concentration is analyzed for the sulfur dioxide, nitrogen oxides. And this is a ozone impinger, this amber color. And here the basically the trap is provided where the sulfur dioxide trapping is done. And whenever ozone total oxidant we are doing, we have to see that we also monitor NO2. The values obtained need to be subtracted of the NO2 from that value, and one can report this. Temperature is maintained 50 degree. You see that this plate temperature thermoelectrically is maintained at 15 degrees centigrade. Flow rate one can set in this. So this way the gases pollutant sampling is done. These are the barriers one can at the outlet it is fitted this silica gel trap. What happens that some particles also escape from the impinger, then they deposit on these needles, and ultimately flow reduces. If we are using this trap, flow reduction is not taking place. One can even use the filters also in this. So these are then there are the basically benzene sampling tube. They are activated charcoal tubes, 200 up to 200 ml. They can operate for 50 ml per minute, 200 ml per minute. But 1 hour or 2 hour sample can be collected. The backup portion is there. Pressure drop can be measured. Time we can find it out, and ultimately find out how much air gone, and one can find it out the benzene concentration in this. Recently, we have also developed a unit for the analytical grade water. You connect to a tap, and you will get the grade 1 water less than zero point 0.1, or grade 2 water less than 1 micro, this micromoles per centimeter conductivity. No other things are required, and ultimately this is good for the laboratory work. This is very recently we developed. Then we also developed a 4-channel speciation sampler, which is very good to find it out who has contributed these labels. If it is road dust, or it is a biomass burning, or it is a vehicle emissions, or it is a transported pollutants. So one can keep the two filters for PM 2.5, two for PM 10, where one can put the PTFE, another one can put the quartz, black carbon one can find it out, nylon we can find out, anions we can find it out, total dust PM 10 we can find it out. Basically put to the x-ray we can find out all the heavy metals, anions, cations one can find out. So if we know this fingerprinting of the sample, then we can correlate that who has contributed in that area. If the concentration of say potassium is very high, we can say that yes, biomass burning took place somewhere, because of that this concentration is visible. These equipments are used for the source apportionment studies at number of research and IIT and the research organization. Then the direct reading equipment also be developed, where we can do based on the laser based sensor PM10, PM2.5. And now we also have a advanced equipment where we can do 10, 12 parameters together. That is basically PM10, PM2.5, PM1, SO2, NO2, ozone, CO, CO2, oxygen, then formaldehyde, and total BOC. And that is a battery operated, and ultimately one can do that. So these were the something on the instrument. Now for the control we have left, so I think 5-6 minutes, so I will give you some glimpse of it, and then we will be able to reach on that. So let us we have to really select presentation. I'll take 1 minute only to really select. Forget to take that. So it is It is visible, sir?
Yes, sir. Yes, sir. Very
Okay,
well. Very
okay.
well.
Okay, so only a few slides I want to run through in 5 6 minutes. You see that we talk in the morning that urban air pollution management in Delhi. Of course, I'm giving only my some lecture we made earlier. This I want to start from here. What is the present scenario? Delhi NCR is known for the low mixing height. It is a kind of a one side. It is a high, so it is a kind of a bowl shaped topography where the somewhere it is higher altitude and somewhere lower. So whatever is coming inside, it is very difficult to really move out. So all these air pollutants which are generated, they remain trapped into the atmosphere. Wind speeds are also low, result very poor dispersion. This happens basically in winters. So unfavorable meteorological condition. Firecrackers during Deepavali in the start of the winter aggravate the air pollution problem in Delhi. Crop residue burning is contributing as high as 15-16% in raising fine dust and the black carbon in Delhi atmosphere. Due to policy incentive, no farmer to farmers for the rice growing. You see in the Punjab is happening. They are basically policy incentive farmers are given for rice growing.
It is
Sowing of
requested
the
to
rice
kindly
crop
switch off
is
your mic, please.
uh, uh,
All the participants are requested to switch off your mic, please.
sowing of the rice crop is not allowed till start of the monsoon, result delayed crop harvesting in Punjab. Hence, in the post monsoon, leaving no time to farmers for collecting crop residue from the field. Burning is the only option left for them, because what happens, they are, because of the water scarcity, the government, state government, they do not want that they should start using water in the summer, in the month of May June. So only they start cultivating in July. So their change is required. Then at least time will remain for the farmers to really manage their basically crop residue, because they were not left with time. Construction in residential and commercial area are significant. Activity remain full here. uh, Material handling and stocks of the dust, cement, sand, demolished material, and other earthwork found releasing air pollutants in large quantity. This results serious impact on air quality. Some activities I have listed here. After this slide, I will go to the control. NCR roads and the streets are known to remain choked for 16 hours plus each day with no parking spaces left. Carbon particles, gases, pollutant, greenhouse gases are continuously emitted at low heights. Delhi has about 1.2 crore plus vehicles. 60 to 65% of these remain on the road. About 20-25 lakhs vehicles enter Delhi daily, and from other areas impact air quality critically. Diesel vehicles, cars, and the small trucks emissions all impact air quality significantly. You see that there is a very big vehicle activity in the city of Delhi. Ahmedabad is also like that, but of course, compared to Delhi, it is small. Total area of Delhi is around 1500 square kilometer, with total length of the road around 17,000 kilometer. Tailpipe and the road dust emissions are at low heights. They are significant. All houses are filled with the cocktail of the air, one coming from the own house kitchen and other from outside polluted air of the area, and very little room left for the exhausting of air, because we are having kind of the living that we always keep our door closed, and this, whenever pollutants came inside, then very difficult for them to really go out. All dusts are known to be piled up in and around city in open areas. You see, wherever you go to Delhi or any urban area, everywhere dust is lying. On the roofs, you can see dust. You can see on the buildings. You can see on the roads. You can see on the houses. Winds make this dust resuspended in air again and again, aggravating air pollution in Delhi or in any urban area. In winters, biomass burning in Delhi and the suburb of Delhi also contributes significantly in raising black carbon and other pollutants levels. Waste generated in Delhi is about 11,000 ton per day, collected and dumped in different corners of Delhi, found burning continuously contribute raising air pollutant level. Delhi have large number of the dhaba, roadside restaurant, hotels, street vendor offering food items cooked locally using poor design chula burners, and tandoors works on the coal, wood, and LPG giving significant smoke emissions impact air quality badly. So you understood that every city is having these kind of the things. Now, what need to be done? Some points we are highlighting. Delhi and NCR have network of the road. Each road must have the pleasure plantation along the road and also on dividers on the road. Beautiful flowering plants and wider lush green leafy plants be planted to the increase aesthetic look and also to control air pollutant level. Plant must act as barrier between footpath and the road. Road-wise contact may be possible. Easy solution for quick plantation and for their upkeep. Some example photo I can show you. You see that what I want to say. You go to any airport. You go to Delhi airport, go to Bangalore, Hyderabad, anywhere. Very good plantation you can see, you can feel. Why that kind of the plantation cannot be done in the city? Of course, it requires lot of money, lot of efforts. They should be given to the private contractor. They should maintain these roads, the plantation. I want to show you this plantation. You see, this is the side of the road. What kind of the plantation? You see, this entire road is showing that very good plantation. This is close to a airport only. But I took photo from there, and you see these are the on the footpath. These plantation. If you are increasing the plantation, maintaining the road clean, the contribution of these roads to the raising dust level will reduce. Do you see that between two roads? These kind of the plantation, if can be done, one can be able to reduce the dust levels and the other pollutant in that area. Let us go back to that. And this road must be back vast, because what happens that the dust lying on the road keep on lifting with the basically movement of the vehicle. Weight of more vehicle, more speed, more dust will be lift up. So that we have to reduce by cleaning the road. Wet washing is very much required once in a week or so. Ponds and the water bodies need to be made. They act as a sinking. So in the city, they should be made. All the chaurahas should have the fountain, so that at least this water act to really act as a sinking of the pollutant, and then the atmosphere can be improved. So this I've already shown. Overloaded vehicle must not be plied on the roads, so that emissions are not increased. You should see that the city, no vehicle should have the overloading. Diesel vehicle must have the diesel particulate filter, and cities should not allow any vehicle coming from the outside without diesel particulate filters. I think a lot of dust can be trapped. Public vehicle, truck, tempo, buses, auto rickshaw must stop only at defined places, so they can reduce the congestion. They are stopping anywhere. The bus is halt somewhere, and they taking passenger create lot of problems. Material shifting for the construction site must be done during 10 p.m. to 5 p.m. They are This construction activity is contributing significant in raising dust levels in the urban area. Construction site, this base segregation and management must be done at RWA level, resident level, to reduce generation. Garbage and the base collection bins must be provided. All needed place, so that the polythene bags and other waste are not dumped on roads and the street. Biomass burning must not be allowed in cities. Security guard and other things in the winter, they should be provided electrical heating. Restaurant, dhaba must use electric tandoor and the electric heating top heating top for cooking. Use of coal should be banned. Street vendor of chaat and other food item must use LPG. DG set operations should be done in the winters on the CNG or LNG or the whatever other gases fuel. Thermal power plant must have the desulfurization unit, so that these gases pollutant emissions are not taking place, and they are not really. Investment needed on the management and control rather than on the regular monitoring. More monitorings are not required if the labels are very high. I am a monitoring company, but I very confidently say at this is the time where we have to really contribute towards the control. We do monitoring only to know the what is the whether it is reduced significantly or how much reduction took place. Further strengthening monitoring network on those areas where already machines are there, or the where stations are there not required. You can add some background locations to really see that how we are better and how we are bad. Real-time source apportionment measurement may be necessary for the city like Delhi. One station they have already set. So online they are getting source apportionment study. Online they are getting which values are increasing and which source is contributing. That source you will be able to do it. DPCC has put one station online where all these parameters are monitored, and then the model is predicting, and ultimately action one can take. So then the NCR should have uniform enforcement, because NCR, there's a big area. I think we should not discuss it, because NCT is very small area, 1500 kilometer, and that NCR is for 55,000 square kilometer. Air pollution found increasing due to people migration in Delhi NCR. Since resources are limited, migration has to be discouraged. For that, the administration has to look into it. Public participation is mandatory, and this public transport need to be improved. Last mile connectivity need to be exercised, and then the waste composting need to be done at RWA level. Plant must be planted in and around houses, colony, to increase aesthetic look and for as a air pollution control. Dust trap spray guns at each high-rise building. Light mask must be installed and used to mitigate the air pollution. Discouraging biomass burning in winter, I've already highlighted. Congestion has to be reduced. Shift public works related offices, should not allow more offices, more things to come into the city. New setups should not be permitted in Delhi NCR. Same thing for the other urban areas. Shift winter cap. These are all those for Delhi only. Discourage migration of the people in NCR by asking one-time migration fee or something like that. Synchronization of the traffic light is very important to reduce congestion. Diesel vehicles should have particulate filter. Incentive to industries on adopting cleaner production should be promoted. Look and inspire to example creating national or international city Metrology who fought air pollution and achieved better air quality. You see that many cities, even Shanghai in China and other areas, they were very polluted sometime, but now they are not polluted. What they have done, we should also copy and adopt and take lesson from that. Encourage crop rotation and discourage rice cultivation in area close to the NCR. This will basically impact and reduce that urban pollution. Electrical vehicles should be used for this, so that the vehicle emissions are not there. Fuel oil rate need to be increased, and the additional money which is coming should be put for the plantation and other things. Monitoring need to be reduced, that I already said. Polluting industries need to be shifted if they are in the city. So these are the all which I thought that I will be able to share, and now I will be stop sharing, and then we can now discuss if some points or some questions are there.
Thank you very much, sir, for your brief and wonderful presentation. I think it is very important and very enlightening. And how to resolve the issue, you have make it very clear. I would like to request all the participants to kindly switch on their videos. If possible, kindly switch on your videos. And if anybody would wish to speak, he or she is free to speak. Anyone? Otherwise, I will share this presentation after this program through our website. I think all are aware of the website address. This is given on all pamphlets. You can find all the presentations as well as videos. Even if you wish to say something or you wish to add something, wish to ask, you kindly send me the WhatsApp or send me an email. With this, I would like to thank all the participants, my speaker of today, Dr. Ajit Prasad. And next week on Saturday, we are planning to organize Consumer Day. So I will let you know what are the programs on that day. There will be some other programs apart from this 1.5 hour training program or 1.5 hour this understanding. There will be a few other speakers who will speak on that day on World Consumer Day in the next week Saturday. With this, thank you very much. Thank you all. We will meet in the next week on Saturday. Thank you. Thank you very much. Thank you all. Bye.
Thank you, Ashutosh. It's a wonderful, basically.
Thank you, sir. Thank you. Thank you very much. Thank you.
Yeah.
I will share this presentation to all.
Okay, sir. Thank you.
Kindly share it to me, sir, please.
Thank you, sir.
Thank you, Ashutosh,
Thank
sir.
you. Thank you. Thank you very much.
Ashutosh, thank you for taking so much credential to impart such type of trainings to us, and these trainings are very learning, sir.
Thank you, sir.
मोबाइल चार्ज करना
Thank you, sir, for amazing knowledge.
एक इसके लिए इंसान
हेलो सर, हेलो
कहाँ पे है
हेलो
सीटू
जी।
से क्या
Yes, Vinod Kumar ji.
नहीं यार सीटू से नहीं
हेलो राजेंद्र प्रसाद फ्रॉम
चाचा
हवा
वाला है
रिसर्च सेंटर।
उनका चाचा सीटू से नहीं है
Thank you, sir.
ये जल जाता है
Thank you very much. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you so much for your
Thank you.
presentation.
हम्म?